Have you ever wondered about the factors that affect the heating effect of an electric current? It's a fascinating phenomenon based on Joule's law. This heating effect, also known as Joule's heating, occurs when electric current is passed through a conductor. There are three main factors that influence this heating effect: the amount of current that's flowing, the length of the resistance wire, and the duration for which the current is passed. Now let's dive deeper into each of these factors. First up, the amount of current. This plays a significant role in the heating effect of an electric current. Let's visualize a wire as a bustling highway, with electrons as cars. When more cars, or in this case electrons, are moving through the highway, there's bound to be more friction. This friction, in the form of collisions between the electrons and the atoms of the wire, causes the atoms to vibrate more rapidly. And what's the result of this increased vibration? You've guessed it, heat. So it's quite straightforward. The more current that flows through a wire, the more heat it produces. In other words, crank up the current and you turn up the heat. So, more current equals more heat. Next, let's talk about the length of the resistance wire. The length plays a significant role in determining the heating effect of an electric current. Picture this: the longer the wire, the more resistance it has. And why is that? Well, it's because the electrons have a longer distance to travel, so they end up colliding with more atoms along the way. Every collision generates heat, so the more collisions there are, the more heat we see. It's a bit like a marathon runner. The longer the race, the more energy they expend and the hotter they get. So in the world of electric currents, a marathon wire would generate more heat. Therefore, a longer wire produces more heat. Finally, the time for which the current is passed. Now this is an interesting factor. Picture this: the longer the current is passed through the wire, the more heat it generates. Why, you ask? Well, the reason is pretty simple. The longer the current flows, the more opportunities electrons have to collide with the atoms of the wire. And these collisions, they're the real heat producers. So, it's quite straightforward. In essence, more time equals more heat. To sum it all up, the heating effect of an electric current is influenced by three main factors: the amount of current flowing through the wire, the length of the resistance wire, and the duration for which the current is passed. These aspects interplay to determine the heat produced by an electric current. As the current length or time increases, so does the heat generated. With these factors in mind, you now have a better understanding of the heating effect of an electric current. Thanks for tuning in.